Hi everyone, my name is Al-Amin bin Azmi. For this presentation, we will be discussing about Integrated Service Design, DCT523, focusing on the building service system, specifically the HVAC system. Our case study is the Exchange 106. This project was prepared by our group member and supervised by Dr. Nur Hashimah binti Ahmad Zamri. Next, we move to slide number 2, which is Introduction Project Background. The Exchange 106 is a super tall skyscraper located in Tun Razak Exchange, TRX, Kuala Lumpur. It was height of approximately 445.5 meter and consists of 106 story, making it one of the tallest building in Malaysia. Previously known as the TRX Signature Tower, the project was later developed by Mulia Group. Construction took place between 2016 and 2019, which structural completion achieved in December 2017. The building is also known for its rapid flow cycle and a record-breaking concrete pour during construction. So, what is HVAC system? HVAC stands for heating, ventilation, air conditioning. It is an integrated building system that controls indoor temperature, humidity, airflow, and air quality. Heating helps maintain comfortable indoor temperature, while ventilation supplies fresh air and remove contaminants. Air conditioning cools the space and regulates humidity. HVAC systems are essential for occupation comfort, healthy, and energy efficiency, especially in the high-rise and commercial building like the Exchange 106.
My name is Hvac bin Samuri and I will explain about design stage. This slide explains the Hvac design stage for the Exchange 106. At the design stage, the Hvac system was planned to meet the performance demand of a super tall building. High efficiency chiller and the centralized chilled water system were selected to provide uniform and reliable cooling across all 106 floors. To reduce solar heat gain and cooling demand, the Hvac design was closely integrated with the building facade. A high-performance double-glazed and insulated facade was incorporated to improve thermal efficiency. A comprehensive building management system or BMS was also included in the design. The system monitors temperature, humidity, carbon dioxide level, and occupancy to enable intelligent real-time control of indoor environment conditions. Variable of volume or VAV units are introduced to allow precise airflow control based on occupancy level. In addition, fresh air intake was designed to operate automatically according to real-time carbon dioxide reading. Ensure good indoor air quality while minimizing energy waste. Overall, the design stage focused on achieving occupant comfort, energy efficiency, and system integration through smart and sustainable Hvac strategy. So next, we move on to the next slide. I will explain about the construction stage. As we can see, there is 6 construction stages that will be explained in this section. This section explains how the Hvac system was installed during the construction phase. following the progress of the building work to ensure proper coordination and efficient system integration. So, let's move on to the first construction stage, which is pre-construction, design finalization and coordination. During this phase, the Hvac system design is finalized, including system selection, cooling capacities, zoning strategies, and overall energy performance to meet the demand of the super tall building like the Exchange 106. Close coordination is carried out between Hvac, structural, architectural, and electrical system to ensure sufficient space for ductwork, piping, plant rooms, riser, and service shaft without conflicts. For fire and life safety system are also integrated at this stage. This includes smoke control, stairwell pressurization, and emergency ventilation system to comply with safety regulation. In addition, the facade design is aligned with the Hvac system to improve energy efficiency by reducing heat gain and cooling load. Building management system or BMS planning and BIM-based clash detection are used extensively to identify the resolve potential coordination issue before construction begins. Overall, the pre-construction phase is essential to ensure smooth installation, minimize on-site changes, and achieve efficient system performance throughout the building life cycle.
My name is Mohammad Amiz Wadli, and I will talk about base building and core shell MEP works. The base building and core shell MEP works is where a high-rise truly comes to life. This phase installs the essential mechanical, electrical, and plumbing system that form the permanent backbone of the building, supporting every feature tenant above. At the lower levels and mechanical floors, large-scale equipment such as chillers, pumps, cooling towers, and buffer tanks are carefully installed. These components act as the heart of the building, delivering cooling and ventilation efficiently across all floors. Another crucial step is the installation of vertical risers and service shafts. These pathways carry pipes, ducts, cables, and control system from the basement to the top of the tower. Precise alignment at this stage ensures smooth distribution, prevents clashes, and allows construction to progress seamlessly upward. Together, this work set the foundation for performance, reliability, and long-term efficiency in a high-rise building. Next, as the structure rises, Hvac installation moves in parallel floor by floor, allowing building services to be integrated as each level is completed. This approach speeds up construction and helps identify coordination issues early. During structural works, sleeves, openings, and embedded supports are installed within slabs and beams. This early planning allows ducts and pipes to pass smoothly through the structure without later cutting or disruption. Next, ductwork for supply, return, and exhaust air is installed progressively, with careful attention to alignment and sealing to ensure efficient airflow. Chilled water pipes then follow along corridors and risers, complete with proper supports, insulation, and pressure testing before ceilings are closed. Hvac equipment such as AHUs, FCUs, and VAV box is positioned early to suit ceiling space and building layouts. Continuous coordination with other trades, often supported by beam, ensures clash-free installation, while regular quality and safety checks keep work consistent and reliable as construction advances upward. Furthermore, the facade and envelope integration. In this stage, Hvac systems are carefully integrated with the building facade to reduce thermal load and improve energy efficiency. close coordination between mechanical engineers and facade designers ensures cooling systems are sized accurately based on real thermal performance. High performance low E-glazing and insulated facade systems are installed to limit solar heat gain while allowing natural daylight into the building. To further control heat, shading elements such as fins and louvers are added, especially on sun-exposed facades, reducing peak cooling demand. At the same time, airtight sealing and proper insulation minimize air leakage and unwanted heat transfer, helping indoor temperatures remain stable. With lower heat gain from the envelope, Hvac load calculations are refined, allowing system to operate more efficiently. Together, this integration supports occupant comfort, reduces energy consumption, and strengthens the building's long-term sustainability goals.
Hi, my name is Muhammad Tajuk Ahmad. Moving into the testing and commissioning stage, this is where we verify that the theoretical design meets real-world performance. Our process involves 6 critical checks. First, airflow balancing. We ensure uniform air distribution so every occupant experiences the same level of comfort. Next, chiller and AHU testing. We verified the cooling capacity of our high-efficiency chiller and confirm that the air handling unit are providing proper circulation and filtration. Next, smart system integration. We calibrate temperature and humidity sensor through the BMS to ensure all components operate as one coordinate intelligent unit. Lastly, energy performance. We run an audit to confirm the system complies with global green building standard like LEED and GBI. Next, the final handover is the transition point from construction to operation. At this stage, our focus is on long-term reliability. First, certification. We issue all necessary commissioning and compliance certificates to verify the system integrity. Next, knowledge transfer. We don't just hand over the key, we prepare detailed as-built drawing and O&M, operation and maintenance manual. Lastly, training. Training is crucial. We conduct comprehensive training for facilities management personnel to ensure they can manage the tower efficiency for years to come. In conclusion, the Exchange 106 represents the pinnacle of smart Hvac design. By combining a centralized chilled water system with a high-performance double-glazed facade, we significantly reduce heat gain and cooling loads. Through BMS, driver real-time monitoring, and VAV zoning, the building only uses energy where and when it is needed. This integration of BIM, coordination, and automated control ensure that we achieve our 3 core goals. First, thermal comfort, superior air quality, and unmatched sustainability. Thank you for your attention. We are proud to have shared the system behind one of the most iconic landmarks of the KL skyline.